Alright, so this is going to go on the bottom of 6.1.2. And from last week, we did sine. Now we're going to look at cosine, the inverse of it. The arc whose cosine is, and now it should start becoming more automatic that when you see cosine and we're dealing with the circle, you're thinking, that's my x values. So you're dealing with x. Now to kind of make this more meaningful, we're going to connect it to what we did last week. I'm actually just going to kind of give you, I'm going to give you something to evaluate. So find inverse cos of rad 2 over 2. Alright, Yasmin, welcome back. Where is cosine inverse equal to rad 2 over 2? Uh-huh. So, what's the radian measure there? Okay. That's one of them. Where's the other one? Close. 7 pi over 4. So pi over 4 is one of them. Actually, going to do it in black. And then the other solution is 7 pi over 4. So I'm going to write this in also so you see the coordinates. This is 7 pi over 4. You'll notice this is different than the sine graph because the line's vertical instead of horizontal. Okay, so there are two solutions that we know of, but the calculator only gives you one because it restricts the range. So how did we restrict the range last week to only get one solution? Yeah, for cosine, what was the range that we restricted? Where did we start? 0 pi is where we started. And how far did we move? To pi. So the calculator only gives you the solution in this interval, 0 pi to pi. And we're going to call this our, you look at our domain and range. So our domain is -1 to 1. And our restricted range is 0 pi to pi. And that's because your calculator is function-based. So if we're restricting our range, what's the only solution that really works for us then here? Pi over 4. So it's pi over 4 and 7 pi over 4. But we can, since we're working under a restricted range, to make it a function, otherwise it fails the vertical line test, one output is pi over 4. Daniel, what's your question? This here. When we graphed the inverse of cosine, we got something that kind of looked like almost like a helix, or it almost looked like that medical symbol that what pharmacists use, right? Vertical line test fails miserably. So what we had to do is we had to go inside the math, and we had to restrict the range, so we cut it. And actually, that wouldn't be the best place to cut it. It'd be like right here. I'm just kind of sketching it. And we are only looking at this little area. And if we're only looking at that area, does that pass the vertical line test? There's only one output. That's why when we restricted the range, we're only getting one solution. Okay? Yes. Which brings up an interesting question. Could we restrict the bottom? Could we just do pi to 2 pi and get this bottom solution? Could we? It would pass, right? But your calculator always starts at 0. So the calculator is going to do 0 to pi.